So, ladies and gentlemen, welcome. My name is Matthias Tomenendal, and I'm very happy to be your moderator of this exciting panel discussion on different electrolyzer technologies. Actually, we want to discuss which technology will prevail in the future. AEM, PEM, Alkaline, SOEC. We will have a discussion, maybe in the beginning also a little bit of battle of these three experts here on stage, and we would like to involve you. So please feel free to ask questions all the time and participate in the two polls that we will also have during the discussion. But now I'd like to welcome and introduce the experts from right to left. It's Tim Cholibois. He is the Vice President of Strategy and Business Development at Enapter. Welcome, Tim. Then we have Thyssen, the Vice President Sales of Sunfire. Welcome, Wolf. And Marius, the CTO of H-TEC Systems. And as I already said in the beginning, I would like you to battle each other a little bit, be proponents of your technologies with a short introductory statement introducing maybe your company and on your view on your distinct technologies. Tim, maybe you start for the AEM technology.
We are a bit the new kid on the block, so yeah, I represent Enapter today. I'm very happy to be here. And Enapter, there's two things you have to remember about us. Firstly, we have a deeply modular approach to building our electrolyzers. It's all based on a standardized stack that's in the kilowatt range, and we combine it into bigger systems. And the second argument for Enapter is that we are the commercial leader in the AEM technology. We've commercialized the AEM technology, you could say, with our electrolyzers. And AEM, if you look at experts, evaluations and assessments of the four competing electrolyzer technologies, although I don't know there's much competition because we need them all. AEM is generally viewed as the technology with the most cost reduction potential in the future.
Oh, very good. So that was a contribution from the right corner, basically. Contribution from the middle, Wolf. Please make your statement for the Alkaline technology.
Yeah, thank you very much for having Sunfire here today. Sunfire basically representing two technologies today here for Alkaline, pressurized Alkaline to be precise. I was about to say that we believe there's a place for all the different technologies. Luckily, we see the start of the hydrogen economy. However, of course, we believe that our technologies will hopefully grab the largest market share. So again, that's why we also have two technologies in our portfolio. Pressurized Alkaline, we believe, or I think this is the most mature technology now ready to really support the industrial projects in hard-to-abate sectors such as refining and other energy applications, molecular applications. And we think that technology has been around for a while. It's basically the workhorse, and we get that feedback from the market that it is considered the workhorse to now really support the kickstart. And then hopefully in the future, we also as significantly will contribute with high-temperature electrolysis for all the applications where you have off-heat available.
Okay, maybe so far. Thank you very much, Marius. And an introductory Wolf, and an introductory statement from Marius as well.
Yeah, thank you very much for inviting me as well today. I'm Marius, CTO of H-TEC. I would like to join in what you just said, that even though everybody likes battles, I think we need all the players in the industry to overcome the challenge that we have as mankind. So yeah, I think we need all the technologies. But of course, we are convinced that PEM is the path to go for us. H-TEC Systems has been a pioneer in the field of PEM electrolysis with over 25 years of experience. And we combine being independent, fast-growing and focused organization, but at the same time being part of MAN Energy Solutions, which gives us access to large project experience, to a global industrial customer base and a global service network. And ultimately, we are also part of Volkswagen, which gives us access to a broad toolkit in the field of industrialization, on R&D side, on production scaling side, and also supply chain management. We think that we have what it takes to come up with a very bold and ambitious claim. We want to abate 1% of man-made greenhouse gas emissions with the help of our products.
Okay, thank you very much. So we already heard we need all technologies. Maybe in the end that will be part of the answer. But of course, the question is which one maybe will be more dominant, which one will prevail. Let's ask the audience. Maybe we have a first poll. What do you think? Which technology will prevail in the future? Let's say something like 2040, in 15 years or so. Which one, if you may only choose one, here would you prefer, or would you say that will prevail? And then we'll see that and have a discussion around. In the meantime, maybe we start our discussion on advantages and disadvantages of the technologies. Then we will also go maybe into some projects, use cases, and in the end also criteria for business cases and decisions of customers, or the customer's view, maybe to get a detailed view then later. Maybe I start with the technology that is here still on the bottom of the list, so new kids on the block.
Sure.
What are the key advantages, Tim, that you would highlight for the AEM technology?
I mean, the AEM technology is basically an evolution of both alkaline and PEM. One of the key highlights is that it has the same dynamic response as PEM, so it's perfectly suitable to integrate intermittent renewable energies. If we look at our electrolyzers, you can see that the range at which they operate is larger than anybody else's, because we can operate from 3 to 100%. So that means we can really maximize the output from the renewable assets that you combine with our electrolyzers. And then the second key advantage, I would say, is due to our patent, which is the dry cathode. We do not rely on any platinum group metals, and we don't have iridium in our catalysts. So that means that the cost base is very different to PEM electrolyzers.
And how advanced is the technology at the moment? I think that's one of the things to be discussed at the moment. Here we look at the future still, but how far advanced is it at the moment?
I mean, that is the, I think, uniqueness of Enapter, that we started really, really small. As I said before, we have a standardized stack size, 2.4 kilowatts, and we started delivering these in 2017. So I actually looked at the statistics yesterday. There were 6,600 stack equivalents delivered to our clients. So they're up and running in the field. So I would say it's as advanced as it can get. But of course, as we combine them into larger systems, which we've launched last year, a 120 kilowatt system and a 1 megawatt system, we are currently delivering the first one to our clients. So both of them have been run as a prototype at our facilities and now have been delivered and are in commissioning. So I think we're closely approaching TRL 8 and these ones as well, as the other ones, the smaller electrolyzers, are definitely.
All right, so that's where you already are, I would say, with regard to technological advancement, the winner of this little battle here. Could you say why are you the winner? What do you think? What are the key advantages in that sense of the PEM technology?
Yeah, I think when customers approach a project, they might not have a preference in the initial stage for one technology or the other, but we experience that whenever high efficiency is of the essence for the business case, or footprint plays a role, or the hydrogen handover pressure is important to the customer, or even the ease of purification, then we see that PEM has an edge here, and customers then appreciate the PEM advantages. And one aspect that I would like to mention, because it is increasingly gaining importance in our perception, is due to the rise of renewable power and share in the grid, the dynamics of PEM electrolyzers and their ability to stabilize or help stabilizing the grid, and even offering flexibilization of customers' business cases, is something where we experience where the interest is strongly rising.
Okay, thank you. And Wolf, the maturest technology in that sense, what are the key advantages from your perspective, and why you should have won the battle?
Absolutely, yeah. Interesting to see that result here. Yes, I mean, we believe that in order to be a part of the solution in the future, you also need to be part of the solution now. I agree that we all need to work together to make this hydrogen economy happen. However, we think, looking at the various projects now going ahead on the market, especially looking at the larger ones in the double-digit or triple-digit megawatt range that really try to make the point and show the case that you can do hydrogen at large scale. That for that you need a solution that is reliable and is also available with large stacks. And that from our perspective is alkaline, and we see a couple of advantages for some use cases in the pressure element. I mean, some of these technologies are pressurized, others aren't, but the pressure we can deliver at 30 bar is perfect for a refinery, for instance, which are also one of the first movers at the moment with adopting hydrogen. Hence, this is where we see the relevance now, and but we also believe that there's great development potential in alkaline in the future.
Is maybe one of the answers to which technology will prevail? I mean, yes, for sure it is where it will prevail. I mean, which kind of applications, which kind of scenarios, and maybe one of the questions or scenarios is: will we see a more centralized or decentralized future for the hydrogen industry, or in which areas will we? And maybe there, is it the case, kind of a more centralized structure, we would see advantages of the alkaline technology?
Yeah, we believe that at least this is where at the moment we are focusing on that part of the industry. Centralized or semi-centralized electrolysis plants, like close to refinery or close to the to-be backbone, which is forming in a couple of countries in Europe. So we see sort of this 50 to 200 megawatt project ranges where we focus at the moment with our alkaline offering, because we think it's validated there, and it also offers the advantage that at the moment it comes at the lowest price point. So clear focus on that part of the.
And Marius, are you counting more on a decentralized economy, or for the solutions for the decentralized?
Actually, we see both cases. So we see both decentralized as well as the large big centers.
Tim?
Yeah, I think we are more at the decentralized end of the spectrum. And again, I believe that very much we need these large centralized alkaline production facilities. But I also believe that, for example, if we talk about the backbone, the pipelines we want to build, we have to factor in a certain, the fact that they will not reach everybody, and we still need on-site production. B, we needed to create a resilient energy system. And C, I believe that until we come to that, we really already want to get started. You know, as you see in Germany, there's discussions that the smaller electrolyzers have a much less complicated permitting process, so we can get started now. We have a lot of industrial clients that come to us because they want to start now. And if you also look at political discussions, you know, the hydrogen backbone in Germany, for example, after the power station strategy that the government updated, already there's discussions, is it maybe too large? Do we make it smaller? So I think just to have a resilient system and to be smart and to guarantee a widespread adoption of the hydrogen production technologies, we need to start in a decentralized manner.
Okay, maybe turn to some of the questions from the audience, and I would like to start with one, because we saw other technologies as well. And Wolf from Sunfire, maybe you would also like to mention the SOEC technology here quickly. When will Sunfire be able to sell their SOEC technology at industry level? Finally.
Finally, I love the finally. Well, we are already including our SOEC technology in industrial projects with industrial use cases to show that it's working, and it does. We have a couple of industrial partners where these systems are already applied up to 3 megawatt size, so quite sizable already. However, when Sunfire started out in 2010 as one of the first movers, first advocates of the hydrogen economy, then saw that finally the efforts were bearing fruit a couple of years ago, and then we saw that, you know, technology needs time in maturing and developing. So Sunfire wanted to be part of the economy now, also in a relevant scale. So hence decided to go into low temperature electrolysis as an addition into alkaline. However, still developing SOC technology, learning a lot from the market, learning from use cases, customers, and in a not too distant future, we will also scale up SOC to double and triple digit.
Okay. I mean, when we prepared for the discussion, said, I mean, the question of global competition is probably too big for this short discussion. But now we see this is actually what most of the people in the audience are interested in. So therefore, I'd like to ask the question and ask you all for a comment. So how are you preparing for the flood of Chinese electrolyzers eventually coming into the market at much lower cost? How can we avoid you all going bankrupt or having to move elsewhere? How can we avoid another exodus like in the PV industry? Who would like to make a comment on that? Marius, go ahead.
I can give it a try, but even it's a very broad topic.
Yes.
But I think first and foremost we need to be competitive.
Okay.
I mean, and we need to be brave in order to. We need to come up with the best solutions. On the other side, we think that on the funding scheme side, there's regulation needed that give very strict boundary conditions of how the value chains need to look like and which standards we want to apply, for instance. In order to prevent an exodus, like it's mentioned here with the example of PV.
Okay, Tim also wanted to give it a...
Yeah, I think
Right.
there's a lot to say about the Chinese market. If you look at the cost levels, of course, it's largely alkaline, and they're at 200 compared to 1,000 here in Europe. But then also, if you read into it a bit more, you see that the largest projects in China with Perich and Longi, for example, they have not even been started, they lay dormant. So I think the Chinese still have a lot of issues, technology issues to solve, especially when they want to transition towards the more dynamic technologies like PEM and AEM. Okay. Nevertheless, for us, personally for Enapter, we have a strong partner in China, Wulong, which we have increased our collaboration with to also benefit from the huge learnings that the Chinese market can offer in the future, as yes, they are world leading in streamlining production and achieving the lowest cost base. So yeah, there's a lot of collaboration you see and cross-fertilization between Europe and China as well, both ways.
Wolf.
Yeah, of course, it's a topic out there. However, same view, of course. I mean, if you really compare it like for like, taking into account safety standards, production standards, etc., then the difference becomes not negligible but very small. Okay. And then also, of course, especially now where you want to make your first or second hydrogen project a real success, also in the long term, I think it's a much safer bet to go with a European supply chain, as we offer all here on the stage, and really make the project a success, because it's not only the final investment decision where you decide about the success of a project, but then during execution when it comes to troubleshooting, etc., and then also to maintaining and refurbishing the plant later on.
Okay, good. Thank you for those answers. The next two questions, Marius, for you on the PEM technologies. Maybe you can make a statement on both. How do PEM producers deal with the rare raw materials, which are scarce, and might a strict PFAS restriction be the end of PML?
Maybe starting with a rare metal question. So
yes.
iridium, of course, is the white elephant in the room, but there's strategies to cope with this challenge. One will be to, and we've heard some points about it today, that there's a lot of technology development going on the catalyst side in order to reduce the loading per kilowatt or the loading per active area. And there's a lot of potential to be realized here on the one side. Secondly, getting more power out of the hardware. That is something that can be leveraged by the current densities while still keeping the lifetimes. And thirdly, and this is the most important one, is getting into a circular economy, recycling the iridium that's going into the circle, and then basically just running it around in the economy. And by these measures, the challenge can be mastered. When it comes to PFAS, I think this indeed is an issue, and that's why all the manufacturers have put in their concerns or contradiction to the EU inquiry. And we basically expect that there will be exemptions like that's also on the way for PEM fuel cell, because indeed it would be a challenge as of now. There is technologies on the way, but they will require some further time until they are mature enough, and that's why we think there will be an exception.
Okay, good. Thank you. How does the water quality impact the lifetime of the PEM and AEM stack? Have you experienced issues caused by bad water quality on input? Who would like to go?
I mean, yes, bad water quality definitely impacts the functioning of the electrolyzers, and that's why it should be as pure as possible.
Probably a question from a water purifying company.
Yeah, I mean, definitely. Yeah, I mean, ours is slightly lower the requirements than PEM, but it's almost negligible. You can always work under the assumption that the better the water quality, the better the electrolyzers will work, or the longer. I think that's the same
Anything to add, Marius?
No, I mean, water purity is of the essence.
Yeah.
And we know how to deal with it.
One further question for Sunfire. What's the actual status on the AEM investment, or?
Not sure where this is coming from. Maybe that's an overinterpretation of something. But I mean, we as Sunfire, we also looked 4 or 5 years ago. We looked into PEM, for instance, when Sunfire took the decision to go into low temperature electrolysis. I think all I can say is that we're not turning a blind eye on electrolysis technology, because there will be a lot more technologies coming up in the future, I suppose, beyond of what we know today. And as said in the beginning, we want to be relevant in the future as well. So let's see how electrolysis looks in 20 years from now.
I think it's because last year you announced a collaboration with Fraunhofer now on AEM.
It could be, but investing is probably
maybe that's the wrong
interpretation.
Looking into
early stage.
looking somehow into. Yeah. Okay. Good. So now we talked about kind of technological readiness. Marius also said it's ready. Now come here the questions, of course, on the other criteria or differentiating factors for advantages and disadvantages again. So one is cost, also O&M costs, and the other is durability. How would you comment on those questions? So let's start with the durability question. What is the durability of each electrolysis technology? Tim, maybe we start from the right.
I think the durability of our stacks, if we look at them, how they are operating under stress tests and in the steady state, and then extrapolate, we arrive at exactly the same operating hours as our competitors and the competing technologies. And if we look at the expected OEM costs, then we design our service contracts in line with what we see our competitors are doing. For Enapter, again, the modular nature of the system gives it one key advantage, and that is that the system continues to run when you exchange the stacks, and we design our strings, which are assemblages of 10 stacks at a time, in a way that it's really easy to exchange one stack that might malfunction without endangering the operation of the overall system.
Lost with the overall system, and then maybe the others would like to comment as well, Wolf.
Yeah, I think the beauty of Alkaline is that you don't have to extrapolate data in order to come up with a durability statement because it's proven already. So I mean, it's sometimes I call it the mother of all electrolysis. I mean, it's a technology that has been around for decades, hence the durability of 10 or more, even 15 or 20 years has been proven in the past, and it's also quite sturdy system. The design, it allows refurbishment, so it's a long life, durable option.
Okay, good. PEM?
Yeah, I'd add on what Tim said regarding, I think in the end it's about defining what is the ideal lifetime of a stack and what is the best business case for the customer. How long should a stack survive in order not to be either over-engineered or then not delivering the right average efficiency over its lifetime. This is what the market also still is finding out.
Okay, maybe because you said, what is the business case of the customer? What is the right business case? We have our second poll, and ask the audience again from your perspectives. And here, please type in basically one word, and it could also be a word that is or has already been typed in, because the result will be a word cloud. Yeah, we see all the words spread all over the page. So which criteria do you, and you can type in maybe more than one, which criteria do you use to evaluate your hydrogen business cases? Yeah? So you said there might be different ones. It depends on the business cases. And while the people type in, would maybe some of you give an example of a use case or project or so where which is a very interesting business case with your technology that you would quickly like to highlight here. Yes, please go ahead.
I think there's maybe a new aspect to a business case that is arising. We learned today about the bottlenecks in the grid and curtailments that have to happen, and the beauty of having a highly dynamic system like a PEM electrolyzer that is kind of like in a romantic relationship with the load curves of a renewable energy equipment. And this dynamic behavior and the very wide load range of the PEM electrolyzer allows to offer frequency stabilization services to the market, and those basically are also tradable, and then the owner basically will be in the position to decide flexibly whether or not, and if yes, which part of its capacity he would like to bring into this market, and this would enable then additional revenue streams, and I think this is highly attractive coming up in the market.
Interesting. Sure.
Yeah, I have another one that we've
from
seen
the right corner
on the rise recently, as we launched our latest product, the AEM Flex 120, so 120 kilowatts. We have a lot of demand from industry that want to decarbonize their heat and basically blend it with natural gas. And we're marketing this product with our strong partner H-TEC, who's also here today and has a booth. So we see really a huge market appetite for these smaller solutions for industrial innovators who really want to start now in the heat segment.
Okay, interesting. Wolf, you also get the chance to highlight maybe.
Yeah, LCOH is of course at the core, or total cost of ownership. What we see, one of the advantages of Alkaline is, I mean, it operates at a slightly higher operating temperature. The stacker is about 80 degrees, which is more than PEM, for instance. But that also, I mean, you can turn that into advantage and use actually that temperature, that off heat, for further processes. So our alkaline electrolyzers can produce more than just hydrogen, also oxygen to be used, and at the same pressure of 30 bar and heat. So we see those projects being quite interesting.
So a lot has to do somehow with cost, as we see, and then in different dimensions. Maybe one particular comment from each of you again on cost. You did that already a little bit now, Wolf. And the question was also on the operation side that we saw just before the word cloud. How to look at it? What is maybe also to be expected in the future with cost developments, maybe in the different areas, but from the different technologies? Maybe you'd like to start.
Yeah, I think if we look into the overall cost, capex is the initial cost that needs to be brought into the business case, and I think that the accumulated amount of PEM electrolyzers that have been brought to the market is relatively small as compared to the volume of alkaline electrolyzers, and this, in our expectation, and together with the fact that the whole industry is massively scaling over the entire value chain and over all components, means that the expectable cost regression curve for PEM versus AEL must be steeper, and that's what's also reflected in the various reports that we know.
Yeah, okay. Wolf, anything to add to your statement before? Maybe development of cost.
Well, we see that at the moment it's the most affordable, but we still, even despite the fact that it's been around for decades and decades, that there's still room for improvement and further development, even in alkaline. So we also expect the cost to come down, maybe not as drastically as in PEM, but then again, then you have other advantages.
Tim was already very eager.
I mean, I just think that it's also important to apply a certain dose of realism when it comes to promising these cost reduction curves, because I think we've seen a lot of players over-promising in the last maybe 2 to 3 years, and that can also be damaging to an industry that is currently in a stage of growing and maybe even a nascent industry. So if you look at supply chains and the energy crisis that we were facing, I think we saw actually costs across the bench increase rather than decrease, and it doesn't help if then there's some players who overpromise and then cannot deliver, because that kind of steers expectations in the wrong direction for everyone.
Okay, very good. I think we've just time for one final round of, let's say, final statement of yours. And that will be, of course, a question on the vision for the future, for the industry, but then also maybe for your company. Something that you would like particularly to highlight. And maybe we start this time in the left corner, right next to me, Marius.
I mentioned our very bold vision already in my beginning statement,
yes.
And I think this is the one that we pursue, that makes us getting up every morning, yes. And that makes us want to fulfill our customers' business cases and make them realize, and that's our vision.
Okay, good. Well.
Yeah, thanks. No, we want definitely we continue our work on being a trusted partner to decarbonize the industrial use cases, the hard to abate sectors. We see there the large scale plants already, but we see them growing even further, and we also want to be the right partner for those hydrogen valleys around the world.
Thank you very much. And Tim?
Yeah, so when I analyzed the AEM market and looked into the future 2030, I saw in my analysis roughly 10% market share for AEM, and hopefully Enapter will still be the commercial and technological leader then. But now in the poll I saw 20, so maybe I'm going to readjust this vision a tiny bit and be even more ambitious.
Yes, very good. Thanks a lot to the three of you here on stage. Big applause for our panelists.
Thank you very much.
Thank you all to you. Thank you also to you for participating very actively. And now we have a refreshment break, and then workshops will start, 2 workshops. So if you have signed up, if you have all access tickets, please go to the rooms. But if you don't have them, maybe you can still try. So try at room C5 or C6, ask if there's an open spot, and you might participate in one of the workshops. And if not, there will be also a very interesting program here on main stage starting at 4:15. It will be presentations on technologies, innovations, and use cases. And I'm also looking forward to that and would be happy to welcome you here, see you here again. So all the best. See you then.